Okay, so this is the third part of our model where we have added a activity diagram to our ATM block. So this is just the the steps that you would need to create all of those things that you see on this screen. So we have the activity diagram on the right hand side, and we have a very basic interface that would allow us to change the pin and see what the messages would be displayed on the screen or monitor or display of the ATM machine. So we are using the same project file that we used before. We still have the same structure, we have the same constraints, we have the same parametric diagram. So let me quickly show you, what we built last week. We still are using the same structure. We'll add one more block to this ATM as a component. We'll call it user, just to capture the user interaction with the the computing unit and the display. And we will suppress the constraint blocks over here. They'll still be there, but we'll not show those things. So what I can do is I can delete some of those things which are not required for this extension, or we can create just another block definition diagram and display the things which we would like to have on this block definition diagram without disturbing the overall structure. So let's do that. So I'm going to go back to my model here. Right click it. Okay, so here I'm going to create a new block definition diagram. I'll just call it BDD2 and simply bring my ATM block, just simply drag and drop it here. Take out the part properties if you'd like to see them specifically drawn. I can also make it larger. So we have the ATM here, we have the computing units, the same two blocks that we had before. We are going to add one more block and call it user. So I'm just bringing it here, and I'm connecting this to my ATM using the composition. You may use aggregation. That would be, I guess, more appropriate, but for our simulation purposes, we just keep it aggregate. Now we are going to add some value properties to these three component blocks so that we can implement our process and have the graphical user interface displaying some of those interactions. So let's start with the easy ones. We'll start with the user ID as a value property of block user. So let's do that. So we are going to say it's a user ID, it's of type string, and we will assign some initial value. Let's just give it the 4 stars. It's just a string, and then we will have our display with a new value property. We will call it the display message. These are all the messages that this display will show, and we would like to have a value property, some variable that would keep track of or save those messages. So we'll put initially in it, enter the pin. This is our entire string over here. We don't need the quotes. Since we have assigned it the data type string, it takes the whole string, enter the pin as one single string. The next thing is to have a database, some way of capturing the valid pin so that we can implement our process. So I'm going to add something which will be called user DB. Again, this is just a notional representation of the things which we would consider valid pins, and all I'm doing is I'm simply typing what you see on your screens. And so there will be multiple such strings. Each would be a valid pin, and what we'll do is we'll double click on it, open its specification window, and would try to put a Python list in it where the elements of that list are those valid pins as strings. So this is a little tricky. Just follow the steps. I've located the default value. Click on this arrow. Value specifications go all the way to the bottom. Opaque expression. Then come back to the default value, the 3 dots, and that's where we can select Python as our language, and then simply type a list with those pins which we would consider as valid pins. So all I've done is I have created this list with the square brackets and N001 one string and N002 as the other string, which would be considered valid input user IDs. Once we have done that, now we have this, initialization completed. You cannot just keep on typing it and expect the tool to parse it and figure out that this is a Python list that we will be using in our simulations. Okay, so I think we are done with the value properties. Next, what we have to do is to start creating our activity diagram. For that, we are going to select ATM because we are going to create a behavior for our system, and in our example system is this ATM. And what we do is we right click and we say create a diagram. This time it's an activity diagram, and once we have this frame, let me show you where it is created in our containment tree. Left hand side, ATM. Here is the activity ATM that we have just added. I can give it a name. Let me see if I can. Here it is. Let me just call it ATM activity. This is just the activity. If you open this thing up, that's where the diagram is. So this is your ATM activity diagram. Just to let you know where things are in our containment tree. Next thing, we are going to bring in our swim lanes, and so here is the different parts displayed. So we have to select which parts we would like to be displayed as those owners of those swim lanes. The P's are all checked, so we will keep that. And now you see we have all the you click on the anywhere in the swim lanes, and this is the handle for the entire this frame, and you can move it anywhere you like. I would like to keep my user on the left hand side, so I'll just bring it here. The computing unit is in the middle, display is on the right hand side. Again, this is just how I would arrange these things. You can do it any other way you like. Next thing is we would like to start building our activity diagram. So what I'll do is, since I've already built it before, I'll just put all the opaque actions in here, and then we'll connect them together with the flows. So let me start with the initial node. So we'll have the initial node here. The next is several opaque actions. So let me just create those opaque actions first, so that we can. So here is another. We have opaque actions in the display. Okay, so at least we have things to work with. One more thing that I have added in this example is this accept event action, and this is just something which would help us start the execution, but then hold it until we provide it with a signal over here. This will be useful when we will be building our graphical user interface, because then we can have some kind of a OK button on our graphical user interface, which will provide this signal, and that's how the simulation will start. Again, you don't need to give it any name. Since it's a signal, first of all, let's connect all of these things together. So we have this going directly into the accept event action. I believe we also have a merge node in here, so let's add that merge node also. So here is the merge node. Just be careful, decision and merge nodes both look very similar. What we are adding over here is the merge node, not the decision node. We do have a decision node in this activity diagram, and it's when it comes to that, and then we will add that. So let's just add the control flows for the time being. We are not passing any information, and then we have this control flow that goes to the opaque action, and that's where we are going to start typing some script, and this one simply initializes a variable x with what is already stored in user ID. So when we'll execute it, we'll make sure that it's either a valid user ID or an invalid, depending upon what scenario you would like to run. The next thing is we are going to pass this user ID to our computing unit as an object flow, because we would like to provide this information. So we will use this object flow, connect these two things together, and we'll see that these pins will all automatically be created, added to our action nodes or opaque action nodes. Let's just use the same x, because we have this x initialized over here. The same x will carry the information through this pin, and at the other end we can receive it as x, although you can use any other variable name over here, but why create unnecessary variables in our system. So this x becomes this x over here in the computing unit. Over here we are going to have a check. We are going to check whether this information in x is a valid pin or not. And how do we do that? We are simply, let me type it first, x in user DB. So user DB is our value property that has a list in it, and we are checking if the x value or x string is one of those values in there. And this is a Python script basically. So we have to open our specification, go to the body and language, click on these three buttons, make it Python. Otherwise the built-in default engine may not know exactly what we are trying to do over here. So now this thing will be evaluated by Python. Next thing we are going to do is to have a decision node now, because this decision node is going to check if valid is true or false. And now we are going to bring in our decision node. This decision node needs to see what this variable has in it. Therefore we are going to again use an object flow, and that object flow will carry the value invalid. So we'll use the same valid here, make sure that the spellings are exactly the same. And when this valid comes in, now we can check if valid is true or false, and depending upon the truth value, we can take different routes. So therefore we don't really need what value valid contains. The only thing we need to do is to just reroute our process, so we can use our control flows, because we don't need to carry this information any further. So we are going to have this. So this is our the outputs, the alternative outputs of our decision node. So if you double click on this one, go to the guard. That's where we have to tell our simulator, check the value of valid. If it is true or false, take this path, otherwise take the other path. So what I'm going to do is simply going to put a guard that says not valid, and again this is a script which Python should be evaluating. So I need to go here and make it Python. Any other language, if it has the same syntax for the Boolean operator not, will also evaluate it. But since we are using Python, let's just stick to that. So now you have, if there is a false in it, then not valid will become true, and therefore this path will be taken. If it's already true, we will put the guard here with valid, do the same thing, make this Python, and that's it. So now we have the two decisions. If the value invalid is true, then this path will be taken. And in that case, what we are doing is we are simply saying, here is this message that we are creating. It's a new variable which we are initializing, and we are going to put this information, this string that says processing, and this will actually be the message that we would like the display to take, and then show it on our GUI. Over here, if it's not valid, we would like to have a different message, and this time it will be invalid pin. if you like, you can also make these opaque action and tell this to interpret or evaluate these assignment statements using Python. But we'll just leave it here because I believe the default interpreter will be able to figure out what exactly we are doing over here. The next thing we are doing is we are going to pass this information to the display. When the message is invalid, we are going to send that message again via a object flow because this message should go. We are going to again use the same variable name MSG, and we will take the same, let me just MSG here. This belongs to this pin and this message belongs to this one. Over here, all we are doing is we are simply taking the value property which we have already defined in the display block, and we are putting this message in that. So what we are saying is display message value property, take this string which we have in MSG, and that's it. We'll do the same thing here when it's a valid pin. We'll use the same variable name here, MSG. We are going to use the same thing, display message value property becomes whatever is stored in MSG. And we have one more. So what we would like to do over here is to have some delay. So if the message says processing, we are just faking what would appear at the screen. You need to add more details if you would really like to implement the entire process. For that, I'm going to use my time event, which will give us some delay during simulation. By default, it comes with this at and something in here. This is the absolute time. So what we should be doing is we would like to double click on it and change this at to a relative time, which will be displayed as after. So I'm looking for is relative field, and over here I'm going to make it true, and now it shows after over here, and all I need to do is to simply say what is the time after which this should complete its execution. So I'm simply saying 2 seconds, and S is just for seconds. Okay, next thing is I just need to connect my displayed message opaque action to this, and so once the message is displayed, there will be a 2-second delay, and then we will have this action node which will start executing, and this simply updates the message and simply says display message becomes enter the pin. So it's like somebody was using the machine and then had a long delay, and therefore the machine initializes back to its initial state, and from here it goes back to this decision node. We would again need an OK signal before it processes the new user ID. Similarly, if we have a invalid, the message would be different, but we would like to go back to this initial state, and that's how we have the entire activity diagram completed with very little information, little details, but you can add more details to capture the real processing that takes place. The only thing missing over here is the signal. So here is the accept event action, which is waiting for some signal. We have to first of all define that signal. So what I'm doing is you can create that inside ATM or out here. So let me just add the signal here over here. So right click, create element. Here is the signal. Once you have the signal, I'm simply calling it OK signal. And once you have created the signal, all you have to do is to drag and drop it on this event action node, and now it knows that there is this signal that it needs to wait, and we can manually provide that signal or have a GUI which will provide that OK signal to it. That's it. So now we can run it without the GUI, So let me just make sure that you run it with the context. Otherwise, you know, all the messages, all the code in here will not be interpreted correctly. Okay, so here we have, so it's creating runtime objects. Here we have all the, so you have the user, the default ID. You also see the constraints. We don't want to see all of that information. It was for, you know, the parametric diagram that we created before. Thing what we can do is we can try a valid ID. So N001, since we know that it's one of the elements in that list, hit return, and now start the simulation. So let's do that. Let me have enough space so that we can see. Okay, so let's run it. Slow it down. So now it's waiting for the OK, and that's, so click on the activity if it does not show up and say OK. So that's how we are. So I've just clicked on OK and it got that OK. You see this N001 is passed to the computing unit. It's evaluated by Python interpreter true. The message became processing. It went to the display object. Now it's waiting for 2 seconds, and then it will have a new message. So if you know all the variables were opened over here, you could see all those messages, you know, updating as part of this process. So now what we'll do is we'll just add a GUI and display all of those things on that GUI, and that will be in the second part of this video. So I'll do a second video for that.